Hi everyone, my name is Sarah Ewington and I'm a digital consultant at Beca in our digital products and services team. Today I'm going to be your host and MC for today's webinar on using digital twins to engineer the future. Before we begin though, I'll just give a brief rundown of today's session. So we're going to be painting a vivid picture of engineering over the next 100 years and how contemporary technology is going to have to evolve to meet that future. One example of such technology is digital twins. Digital twins are a representation that look like, behave like, and are connected to the real world. They occupy the interface between the engineer's world and the physical world and can be a really powerful communication and decision-making tool throughout the entire asset lifecycle. So with that in mind, let me introduce our presenters for the day. So we have Stephen Witherden. He's been passionate about digital twins for over 2 decades now, and their application particularly in supporting complex decision-making. He has recently stepped into his new role at Beca of Product Strategy Manager, and he provides our vision for our digital products and services across the entire Beca group with a real strong focus on digital twins. Andrew Cowie works within Beca's industrial digital team and has a focus on applying emerging technologies for our clients. Digital twins is a focus and a passion area for Andrew, and he's been advising clients in this area for several years now. He also sits on a national group that's interested in creating a network of connected digital twins across New Zealand. Cool. Before we begin, we will be asking questions to our presenters at the end of the session, so feel free to drop in your questions in the Q&A function that you'll find at the bottom of your screen. A quick reminder as well that this session will be recorded, and both the recording and the presentation will be provided shortly after the webinar has ended. We've set this up to run for 30 minutes, but depending on the number of questions we get and how we're going for time, we may choose to extend that by just a little bit. So without further ado, I'll now hand over to Stephen Witherden to kick us off.
Thank you, Sarah, for that great introduction. As Sarah said originally, the definition of a digital twin is a high-fidelity representation of a real-world thing that looks like, behaves like, and is connected to the real-world thing in use for decision-making. And to my mind, that decision-making part is so important. As we say in information systems, no process without measurement, no measurement without analysis, no analysis without decision, and no decision without action. So digital twins are action-oriented tools which allow for better decision-making. When we think about fidelity, especially when we think about looks like, we might take the example of that photo we had on the previous slide. So that photo of me is about 10 years old now. So in terms of fidelity, it's sort of stretching the bounds of credulity in terms of parity with the way I look currently today. However, it is a representation, a visual representation of what I look like. Other ways we might have that represent what I look like is we might have a 3D model of me. We might have a model that represents my circulatory system or the contents of my brain. Those are different ways we can have looks like. Behaves like would be if we had a representation of me that also liked chocolate and also liked the color green, or maybe responded with much more fidelity in terms of how I would respond if you asked me a question. Connected to, with respect to me, might be information about my biometrics, such as my heart rate or other sorts of things going on inside my body. Now, with respect to engineering, if we have a digital twin of, say, a bridge, that digital twin from a looks-like perspective could be something as simple as a picture or a 360-degree photo, or it could be something as sophisticated as an engineering model, or it could be a point cloud which represents visually what that building would look like, or sorry, that bridge would look like. From a behaves-like perspective, for our bridge, it might be some sort of finite element analysis which would allow us to understand what would happen if that bridge came under structural load, how would it behave, or it might be what sort of capacity does that bridge have so that we can run, how many vehicles could run across that road or that bridge. Finally, from a connected to perspective, we might have IoT information or SCADA information telling us precisely what's happening on that bridge, be it the stresses it's under or the number of vehicles it's traveling along that bridge. We might also have the same from a factory perspective, looking at things like the operation of the factory itself. So from a connected to perspective from a factory, we once again might have SCADA or IoT data. From a behaves-like perspective, we might have some sort of simulation, some discrete event modeling simulation, or some sort of process modeling simulation, which tells us how that factory might behave in the real world. Now, these tools are really useful for engineers when they're doing their design work, and the value of a digital twin is bringing all these three things together into a cohesive view to help contextualize this information. So on the next slide, we might see how an engineer could use this during the design activity. Usually our engineers are involved in creating the future by starting at the idea of an asset. So typically engineers get involved at the design phase on the top right there, where they're coming up with this idea of how the asset might operate. They model, simulate, or visualize what that asset is going to look like, so that there is the digital twin coming into effect, creating a representation of the thing that's going to happen in the real world, simulating how it might behave and visualizing that. We then assess to understand how it might behave in the real world. We do some planning to see whether that's what we want, and we iterate a number of times in this idea, this virtual idea of the asset, before we go into construction. Now that build step there, that might be something as complex as a construction activity where we're actually building the asset, or it could be something like a maintenance activity, or it could be a modification to an existing asset. Our clients then operate that asset and observe the operation of the asset. Now, traditionally, digital twins sit in the middle there and are connected to the asset, so they could be used during the operations of the asset to understand how they act in the real world. In the future, though, I see digital twins growing further to subsume part of that planning activity, part of the operations activity, and maybe even part of that build activity if we consider things like additive manufacturing, where some construction sites are becoming more like factories, where you're actually building the factory through some level of automation. So this here is, those of you who are familiar with the asset lifecycle will recognize this diagram as the asset lifecycle reimagined as how it works with digital twins. And one of the important things to take away from this is that the digital twin sits in between the idea of the asset and the real world asset, and that allows the engineer to communicate that idea to stakeholders. I should hasten to add that when I say asset, it's not just a representation of an asset. It could be a representation of a business, or the idea of a real world thing in the real world, such as a person. On to the next slide. How might we see engineers working in the future? So this session is all about the future of engineering, and I quite like to use the idea of backcasting, where we look deep into the future using things like science fiction to understand what we imagine the future might look like, and then work backwards to see how would we get there. So this example here is obviously Tony Stark from the movie Iron Man. Tony Stark is an engineer in the story. I would note that Tony Stark is not my idea of what the future of engineering is, because I believe that the future of engineering is much more collaborative. It's not this comprehensive designer who, from their mind, all of the great things come. It's actually much more collaborative, diverse activity of people. But I do note that the use of Jarvis in this movie is quite interesting, and I believe it's going to be part of our future. Using Jarvis, which is artificial intelligence, as a design partner to collaborate in the design activity, coming up with ideas, helping assess those ideas, integrating modeling and simulation, and then even fabricating autonomously that design. So in the movie, the Iron Man suit is fabricated automatically through the use of Jarvis. I believe this technology is definitely accessible to us now, and is going to become even more accessible to us in the future. On the next slide, we have another example of where science fiction is sort of indicating where we might end up with engineering. This is Geordi LaForge from Star Trek. So here, in this story, Geordi LaForge was trying to solve a problem with the engine of the Enterprise. And what he did is he took an engineering model that had been built by scientists in a lab, and he brought it into the holodeck to understand how it worked, to interact with it. That engineering model he was using in an operational context. It was integrated into a real world system, the Enterprise, and it could actually automate or control the Enterprise to some degree. It supported discourse and interrogation through artificial intelligence. And a character in the background there is almost too hard to see, is the character of Leah Brahms. Leah Brahms in the story is the scientist who created the engine in the first place. Now, this representation of Leah Brahms here in the story is actually an artificial construct. It is a digital twin of a person who Geordi LaForge brought into the holodeck to help him understand how the engines would operate in the real world under certain circumstances. Now, you may think that's a bit far-fetched, but I think we're not that far away from having that kind of technology at our fingertips in an engineering context. And just to round it out, we use simulation to identify the results of different design outcomes and act on the real world. On the next slide, this is really where we're at currently in terms of development of digital twins, and you may know already in terms of the Gartner hype cycle, we're right at the crest of the hype cycle in my view in terms of digital twins. Lots of people are excited about them. So that means we're going to end up in the trough of disillusionment at some point where we realize, well, what is actually capable of us right now? I believe at the moment we're able to simulate factories at the factory level, and we're certainly working on that ourselves. In the future, I think in the next decade or so, we'll be able to simulate and create digital twins of infrastructure, eventually cities, finally countries and the human brain. If you believe Ray Kurzweil, originally from Google, by about 2045, we'll have the right level of technology to actually simulate the human brain, which would be quite exciting. And I believe it's going to happen in our lifetime. And the question I would have is, what sort of things do we need in place for that to happen, and what sorts of things does that mean for us as a culture? And onto my last slide, in terms of what that means for Beca and for engineers in the future, this image here on the right-hand side is our imagining or our representation of what we think engineering in the future could be like for our engineers. It's a representation of a number of engineers collaborating around a design model. They're inside the digital twin, so they're embedded inside the digital twin. The character on the very top of the image is an AI character, which is guiding the team through a design activity and providing some inputs and ideas. The character on the bottom left is that Leah Brahms character. That is a representation of a past Beca employee who is embedded into the tool, bringing their expertise in. And that's actually something that I think is really important for us to notice, that the value that engineering provides to the world is going to remain the same. It's the expertise of our people that is going to remain the same. It's simply the way in which that expertise is delivered and mediated through digital twins, which is going to change. So all of those things that we talked about, ubiquitous seamless access to data, natural language interfaces, simulation, artificial intelligence, all of those things are going to change and become more accessible to us. However, the way in which our engineers add value, that expertise, is going to remain substantively the same. And without further ado, I hand over to Andrew to talk about how we're going to get there.
Thanks very much, Stephen. I think I just love hearing Stephen talk about this and just painting that real vivid vision of the future. I think as an engineer, I just really want to be there. I'd love to go back to my desk right now and fire up my own version of Jarvis, and I just imagine how empowering it would be to work in that way, but also how fun it would be to work in that way. Throw questions out there and have a design partner pop up the result of your ideas and move on. I really yearn to be there, and I look forward to being there. But I think that is a picture of the future, and it seems a very long way in the future, I guess, to a lot of us from where we are now, and also the pathway to get there seems quite uncertain. And so I guess that's why with what I wanted to cover today is how do we get there, and also in particular how do we start. That first step is often the most difficult one to take. And so in terms of how we get there, as Stephen touched on, digital twins are really decision support tools. So to break it how we get there, we have to understand how we can make better decisions. And so if we start by looking at how we make decisions today, we make them in a number of ways. We do make some decisions just ourselves, although I'd say that's more of a rarity for sort of complex problems. More often than not, we're working as a team, collaborating, leaning on each other to make a better decision as a team than we would individually. And I guess we also have my little bot down there. He's my sort of automated decisions, and we do automate pretty low level decisions today relative to what we as humans can make. And so how can we use digital twins to improve this? Well, I guess we're just looking for ways that we can combine those elements of a digital twin into something that will support and improve our decisions even just a little bit. So looking for that behaves like, looks like, and connected to elements, and bring them together that lifts us up, and not just lifts us up as individuals like Mr. Stark, but how can we produce a tool that allows our collaborative teams together to make a better decision again. And so once we start doing this, I guess the pathway is clear. We just have to do it more and more, and we create richer and richer digital twins and bring them together in ways that we make better and better decisions every step of the way. I guess in this last piece down here, we do expect that will become sort of more complex, and we'll get more complex over time. So it won't just be one digital twin providing information and then we make the decision. There will be multiple digital twins. They will be communicating together to swap information and then provide that again to our teams and individuals to make decisions. And also we will be working with digital twins in more intimate ways. Okay, so maybe a digital twin provides information to a team of people. That team of people, discuss that to make an interim decision, and then they feed that into another digital twin, which processes the result of their analysis of it, and then provides, an idea to make a decision, the ultimate decision there. And of course, the automation side of things, the digital twin will support the improvement of automated decisions as well. And as we go with AI and things, the power of that decision making will improve as well. And so how do we start? So in terms of how do we start, I've just got two main pieces of advice, and I would say, firstly, think carefully about what digital twin you are trying to create before you get going, and two, look for the building blocks that already exist around you. Okay, and here's where this looks like, connected to, and behaves like can be a really strong framework to apply to both of those questions. And so when we're thinking about what type of digital twin would like to create, you need to think about what type of decisions I'm trying to improve, and how would that create the value that I'm seeking to create. And so the most obvious example of a digital twin would be an asset. And so that in that case, we're saying we're looking for building blocks that look like that asset. We're looking for things that are connected to that asset, and we're also looking for building blocks that behave like that asset. So for behaves like, it could be a process simulation. For looks like, it could be a design model, and for connected to, it could be some IoT information or some SCADA information or something like that. But there are many types of digital twin. You may want to create a digital twin for your business, in which case it's the same question with a different context. What looks like my business? What is connected to my business? And what behaves like my business? It may be you want to create a digital twin to drive better decisions within project work, in which case you're looking for something that looks like my project, behaves like my project, and is connected to my project. So behaves like my project could be a Gantt chart. That's a simulation that allows us to change some parameters and understand what will happen to my project if that change. So we can look for those building blocks around us and bring them together to create value. And I think if you use that framework, I think that you'll start to find that you have quite a lot of building blocks already at your disposal, and then you just have to think about how do I pull them together to support the decisions that I want to make. And so what could a start look like? Here's just an example of a digital twin that we've created for our client. In particular, this is the digital twin of a physical asset. In particular, it's looking at how we can use a digital twin to improve the decision making for a maintenance technician or someone working in that maintenance area. And so in the top left, so on the whole left-hand side, you've got two elements which really fit in that looks like category. The design model at the top, which may give you some extra information in terms of how it was actually designed to perform. Underneath that, a point cloud, which represents the actual how it has been installed in reality. And I would say, even with those two attributes, you're already improving the decision making of the technician. They can plan their work ahead. They can understand what's around that asset before they even get there. In the top right, we've got a PNID, which describes where that asset sits in the process, in the manufacturing process. And so that's a very sort of a baby version of behaves like. Okay, so by understanding where it sits in the process, the maintenance technician can start to understand what will be the effect, or what could be driving the effect that they're trying to diagnose. And by adding that to looks like, they can make a better decision again. And then down below in maintenance tasks, okay, this is really an example of connected to. So we're connecting to the maintenance planning process. We can see the tasks that have been completed on that asset and the tasks that we plan to do in the future. And again, by bringing all those things together, we have greater context, and we provide that little lift up for the technician to make a better better decision. And suddenly we're on this sliding scale. We've made a start in the sliding scale that improves decisions over time, and we'll be at Jarvis before you know it.
Awesome. Thank you, Stephen and Andrew, for those really interesting insights into the world of digital twins. I think it's so fascinating how, you know, we're already there pretty much. We've already got all these building blocks in place, and it's really just about how we put that all together.